Hi, I am Engineer Febus Reidj Cruz from Mapua University School of Electrical, Electronics, and Computer Engineering. I hope that you are having a great day. In this video, you will be familiar with how P-type semiconductors are made and their characteristics. The major types of semiconductors are intrinsic and extrinsic. And the extrinsic semiconductors are either N-type or P-type. The P-type is a semiconductor added with a controlled amount of acceptor atoms, resulting in a greater number of holes than the number of free electrons. Using diffusion as doping process, the dopants like boron enter the semi-molten semiconductor. The dopants to make P-type semiconductors are trivalent atoms, elements under group 3A, such as boron, aluminum, gallium, and indium. The common dopant for P-type is boron because it has the smallest atom in the group, allowing easier entry into the material. After a time, and as the temperature cools down, the boron atom settles with silicon atoms in the crystal. Every boron only has 7 valence electrons, hence with 1 vacancy or hole. The addition of acceptor dopants to intrinsic material yields an extrinsic semiconductor with dopant atoms having incomplete valences, with 7 valence electrons and with 1 hole. Hence, the material is described as positive or P-type. Unlike the intrinsic semiconductors, where the carrier density of free electrons N is equal to the carrier density of holes P, in P-type, the carrier density of holes is more than the carrier density of free electrons. Hence, the holes are the majority carriers in the P-type. The carrier density of holes in P-type is determined by the concentration of acceptor atoms, N sub A. Every acceptor atom provides a hole without a free electron pair. While the carrier density of free electrons in P-type is calculated by dividing the square of intrinsic concentration, N sub I, by the concentration of acceptor atoms. In summary, P-type semiconductors are manufactured by adding trivalent acceptor atoms to intrinsic semiconductors. The concentration of acceptor dopants determines the carrier density of holes in P-type semiconductors. Each acceptor atom provides a hole without a free electron pair, which makes the semiconductor material positive type. The majority charge carriers in P-type are holes, and the minority charge carriers are free electrons. Keep going with this series on basic physics of semiconductors. And before we end this video, please allow me to encourage you to appreciate your studies and enhance your creative and innovative ideas. Thank you and see you again in the next videos. Thank you very much.